Continuing on, well, I'm looking at this problem and same deal. I need t approaches 0 if I go from the left, or t, not x, same thing, xt, who cares, 3 to the t minus 1 over t, and t, 3 to the t minus 1 over t, but it looks like 3 times t. Okay, so how does it work? Well, I'll take a negative 0.1, a negative 0.001, a negative 0.0001. See how that goes. See if the y value levels off, but I have to change my function really quick. So if I was to go ahead, let me put it right here. So here, first I want to plug in a negative 0.1. And I'm going to go ahead and say, let's take 3 raised to the answer minus 1 divided by my answer. There's my answer. How about negative 0.001? .09. Okay, well, the 1 point seems to be accurate. That's good. At least I have leveled a 1 point. Oh, that's what, because I skipped a 0. Remember, I used to do this. I used to do a 1.01. I jumped, but that's okay. How about a negative 0.0001? It looks pretty good. It's leveling off so far 1.98. So it seems this one I don't need to plug in a lot of numbers. Do you see that? No, let's put it there. We go. So it seems I'm accurate to 3 decimals. I'll try this negative 0.00001. Let's do my negative point. And theoretically, I could get this accurate to as many decimals as I like. But it looks like 1.0987 about. Now, if the right side matches, I'm done. I'm in good shape. I want to take the right side and see if that matches. So far this is what I have. So far I know the limit as t approaches 0 from the left, f of x, f of t in this case, is 1.0987. Oh boy, okay, I messed it up. I clicked the wrong thing, that's okay. So far I know that the limit as t approaches 0 from the left of f of t equals 1.098. I'm gonna go with 7. I'm sorry, 6. Okay, how about if I pick 0.1, numbers to the right, 0.001, 0. Well, let's see how that works. If I take 0.1, enter, 1.1, okay, not bad. How about if I take 0.001, 1.09? That's very good. Why is that? Well, I already know the other answer was 1.098. This is 1.099. So it seems you're getting in the right direction. How about 0.0001? Hey, awesome news. It looks like it's leveling off. Same deal. And let me go. So this is this. And how about this? How about 0.00001? So do we see that the right side seems to match? So we would say, since the left and the right match, we say this limit, here we said it is about 0.5, here we say it is 1.0986. If f of x is defined where x is near a number, then the limit as x approaches a from the left equals L, means that if we choose x values very close to a that are less, remember, from the left, that are less than a, then f of x will become very close to L. If the limit as x approaches a number is L, that means the limit from the left must match the limit from the right. So if they ask for a single-sided limit, you could do that. For example, suppose the following values are true. If I take the limit as x approaches 0 from the left, I get a 1. I take the limit as x approaches 0 from the right, I get a 3. What can you conclude? We conclude that the limit does not exist. And we use does not exist like that a lot. Since the limit from the left does not equal the limit from the right. Now, graphically, the same idea. This is given a graph. I have a graph right there. It's really simple to do. Graphically, use the graph of f to state the value of the quantity if it exists. If it does not exist, explain why. What's the limit as x approaches 2 from the right? There's 2 from the right. As I get very, 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 very close to x equal 2, what's y leveling off next to? That would be a 1. What is the limit as x approaches 2 from the left? From the left, that means you're coming across from the left. You're very close to x equal 2. What's the y value? That's still a 1. And if I was to say, what's f of 2? When x equal 2, what does y equal? Well, there's no value there. It does not exist or undefined. What's the limit as x approaches 2? Well, if the limit from the left is 1 and the limit from the right is 1, it is 1. But it doesn't exist. Remember, we never use 2 for a limit. Limit never ever have to do with x equal to exactly, around it. What if I take the limit as x approaches -1, there's -1 from the right. From the right side, I am on the graph. The y value is 1. The limit as x approaches -1 from the left. If I come from the left, the y value is 2. What is f of negative 1? When x equal negative 1, isn't that the included point that's negative 1, 1? What's the limit as x approaches negative 1? Well, you only look at the limit from the left and the limit from the right. It does not exist. Why? Because the limit from the left equal 1, the limit from the right equal 2. If the limits don't match, the limit does not exist. Here's another example. Use the graph of g to find the single-sided limit. If I want to find the limit as x approaches 2, x approaches 2, there's 2. From the right, if I get very, very close to 2, what's the y value? How about the limit as x approaches 2? Oh, I did it backwards, didn't I? From the left. No. Yeah, this one should have been from the right. I'm sorry, from the right. Oh, I did from the right, not from the left. That's a 0 as well. What is the limit as x approaches 1? There is 1. From the right. Coming from the right side, what's the y leveling off next to? What's the limit as x approaches 1? 1 from the left. Coming from the left, isn't that infinity? The equation of the vertical asymptotes, well, you could tell that is x equal negative 2 and x equal 1. So, the idea is, if the limit as x approaches a of f equal plus infinity or minus infinity, then x equal 1 is a vertical asymptote. That's the idea. How about if I wanted to find the following limits? And this is what we're going to conclude with. They only want me to find a single-sided limit, and that is approaching 3 from the right. So if I make my table, I only have to worry about one side. I don't have to worry about two sides. Give me numbers to the right. I'm going to say 3.1, 3.01, 3.001. See if that's enough. If not, I'll pick more. Well, let's see. If I take 3.1, enter. If I take answer plus 2 divided by 3 minus answer, negative 51. And how about if I take 3.01? Negative 501. How about if I take 3.001? Negative 5001. You could keep on doing this until you're convinced of what the value is. Negative 50,001. So I could say with confidence the limit as x approaches 3 from the right of x plus 2 over 3 minus x, it looks like it's heading toward negative infinity. A quick sketch will do it, but if I say determine the limit, you have to show me some work. There it is. What do you do with irrational numbers? You do a nice trick, and that pretty much sets you off. So how does it work? There's pi over 2. I need numbers to the left. How do you do to the left? Well, that's an irrational number. That's an issue. So the way you work around it, you say pi over 2. From the left, minus 0.1. From the right, you add 0.1. Closer. Pi over 2 minus 0.01. Closer. Closer. So let's see how that works. I take pi divided by 2 minus 0.1. That works. Now, my function, there's no secant key. You make sure you are in radians. This will never work unless you are in radians. R stands for radians. Now, secant, there's no secant, but there's 1 divided by the cosine of the answer. And there's the first value. First value I'm getting at 10 point something. Okay, I'll get closer. I'll take pi over 2 minus 0.01. Then I'll evaluate it. I'm getting 100. Okay. Then I take pi over 2 minus 0.001. Evaluate 1,000 points. If I take, are you confident what it is? If not, you keep on doing this until you convince yourself. I'm guessing it's 10,000. So my guess, it's hitting infinity. I would say the limit is theta approaches pi over 2 from the left of the secant of theta equal infinity. Now you could verify your answer. We know this graph has a vertical asymptote at x equal 3, horizontal asymptote y equal -1. When x equals 0, y equal 2/3. The graph looks like this. And when I take the limit as x approaches 3 from the right, there's 3 from the right, y is approaching -infinity. The graph of secant we also know how to do. We know how to graph everything, right? Calculus students. So you sketch the graph of a cosine. This is 2 pi, this is pi, this is pi over 2. The graph starts from the amplitude and heads toward the asymptote. So that's the green part, blue part. This is pi over 2. As you approach x from the left, that's approaching positive. So that's pretty much it.